How has satellite imagery aided Arctic exploration? If you are curious about how satellite imagery has transformed our understanding and navigation of the Arctic, you are in the right place. Let us explore the significant role satellites have played in this harsh and fascinating region. Satellites have become essential tools for monitoring the Arctic environment, especially given the region's remote and inhospitable nature. For instance, the European space agencies, ESA satellites such as Cryosat and Copernicus Sentinel-3 measure Arctic sea ice thickness with remarkable precision. By determining the height of ice surfaces relative to the ocean, these satellites help scientists calculate ice thickness and volume, revealing significant declines in Arctic sea ice, particularly during summer months. These satellites also monitor other vital parameters like surface temperature, albedo, and atmospheric composition. This data helps researchers understand the feedback mechanisms contributing to Arctic amplification, where the Arctic is warming faster than any other part of the planet. For example, the Copernicus Sentinel-3 mission provides crucial information on sea surface temperature, aiding in the analysis of oceanic heat fluxes and their impact on ice melt. NASA's Multi-Angular Imaging Spectroradiometer, MISR, on the Terra satellite is another key player. MISR uses multi-angular imagery to create detailed maps of sea ice roughness across the Arctic. This is particularly useful during the melt season when other methods, like synthetic aperture radar, SAR, struggle to distinguish between melting sea ice and open water. MISR's data can be used more frequently than other methods, providing timely and accurate maps of ice roughness. Satellites also play a critical role in monitoring human activities in the Arctic. The Suomi National Polar Partnership, NPP, satellite, launched by NASA and NOAA, uses its day-night band to capture images of the Arctic even in complete darkness. This capability is vital for observing maritime activities, tracking icebreakers, and detecting illicit industrial activities, all of which are illuminated by lights that the satellite can detect. In practical terms, satellite data like that from RadarSat has made travel safer for Arctic communities. Resource management officers use RadarSat data to identify safe routes on sea ice, checking for conditions such as roughness or thinness before venturing out. This technology has been particularly useful in winter and spring when traditional knowledge of the Arctic icescape is less reliable due to climate change. Satellite imagery has also helped in emergency situations. For example, in 2013, the National Weather Service used Suomi NPP's day-night band imagery to guide a crab fishing vessel out of treacherous waters in the Bering Sea, ensuring the crew's safety. In addition to safety and navigation, satellites have facilitated long-term studies of the Arctic environment. ESA Climate Change Initiative has compiled 40 year-long datasets from numerous satellites, enabling researchers to study long-term trends and variations in the Arctic. This data supports decision-making and the development of effective mitigation and adaptation strategies for managing the Arctic region. Overall, satellite imagery has revolutionized Arctic exploration by providing continuous, detailed, and accurate monitoring of the region's environmental changes, human activities, and safety conditions. These advancements have made it possible to understand and respond to the challenges posed by the rapidly changing Arctic environment.